share my screen. Here it is. Okay. Good. So I'd like to choose a problem and compute an estimate. It says approximate. The area under the graph of 1 over x squared, and here's the graph of 1 over x squared right here, over the interval 1 through 7 by computing the area of each rectangle to 4 decimal places and then adding. Fine. They're not telling us if to use the leftmost point or the rightmost point, but it is specified by looking at the picture. Can anyone tell us which one it is? They haven't mentioned it in words, but when we look at the graph, we know exactly what they mean. Is it the leftmost point or the rightmost point? Can anyone tell us for number 19 on page 402? If we're using the leftmost point or the rightmost point?
The rightmost point.
So look at any rectangle and see where the height is. It has to end on the function. So the height on any of these rectangles, where is it? Is it on the left or is it on the right?
The leftmost point.
Yes, indeed. Let's look at the first rectangle. See, between 1 and 2, the height is here. For the rectangle between 2 and 3, the height is here. So it is indeed the leftmost point. Good. So we have from 1 through 7, how many subintervals? 7 minus 1, right? It's 6 subintervals. So in this case, they want us to find the leftmost point, so the area with the leftmost point with 6 subintervals. So this will be the base, which is 1, times the height, f of 1, f of 2, f of 3, f of 4, f of 5, f of 6. That's it. So f of 1 plus dot, 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 f of 6. Now the function that they gave us is 1 over x squared. Luckily, the base is just 1. So I can disregard that because multiplication by 1 is not going to change anything. So then the area with the leftmost point with 6 subintervals will be f of 1, which is 1, plus f of 2, which is 1/4, plus f of 3, which is 1/9, plus f of 4, which is 1 over 16, plus f of 5, 1 over 25, and the last one, 1 over 36. I'm not going to approximate any of these. I'm just going to put them in the graphing calculator and just calculate. There is no point. Okay. So there is a very elegant way of doing this, but let's just do this for now. Plus 1 divided by 4 plus 1 divided by 9 plus 1 divided by 16 plus 1 divided by 25 and plus 1 divided by 36. Okay, so this is 1.491388. How many decimal digits do they want? 4 decimal digits. Okay, very good. So 1, 2, 3, 4. Because this is 8, I have to increase 3 to 4. So this will be 1.4914. Any questions so far, please? Is this okay? Do you think we need another example of approximating?
Can we do one more?
Absolutely. Absolutely. Good. So I don't want to do 10 subintervals. There is no point. So let's just look at this one. It's the same, it's repetition, right? So it's just that there are so many and there is no point in, once you understand how to determine an area with 4 subintervals, you know how to do everything else. Okay, so let's look at 20. Approximate the area under the graph of our favorite x squared plus 1 over the interval 0 to 5 by computing the area and so on and so forth. Now, again, we have to identify whether we're using leftmost point or rightmost point. And this is number 20, part A. Rightmost point or leftmost point. You look at any rectangle and see where the height is, and then you will know if it's the leftmost point or the rightmost point. Anyone will identify for us?
The rightmost point.
So let's take any subinterval. So if it were the rightmost point, the height would have been here, and this would have been the rectangle. The last one would have been this. For the rightmost point. So again, which one is it?
Left.
Yes, it's still left. I guess they prefer the leftmost point. Fine. So again, so the area with the leftmost point and 5 subintervals is, luckily the base is the same. Always can we have different? Yes, we can, but most probably 99.99% the base will be the same because we divide the distance between 5 and 0, which is 5 units, we divide it by 5 subintervals. So base times height plus base times height plus base times height. So the base is 1 unit. So we have f of 0 plus f of 1 plus f of 2 plus f of 3 plus f of 4. Do not go to f of 5 because you need only 5 subintervals. 1, 2, 3, 4, 5. Height at 0, height at 1, that's the second one. Height at 2, that's the third one. Height at 3, that's the fourth one. And height at 4, that's the fifth one. If you say also f of 5, then you have this, which is not existent. Then you are including 6 subintervals instead of 5. So careful. Okay, so the function is f of x equals x squared plus 1. So then f of 0 is 1 plus f of 1 is 2 plus f of 2 is 5 plus f of 3 is 10 plus f of 4 is 17. So 17 plus 3 is 20, 30, 35, which we did. A similar situation. We had a similar situation a few minutes ago. I meant last time, of course. How are we feeling about this now? Is this okay? Is that a yes? Is that a no?
Yes. Yes, thank you.
Okay, perfect. Very good. So let's continue. Now, in the same way, I would like us to look at a couple of word problems. And then we can continue. I don't know, total profit from marginal profit. Same type of problem as before from the previous section. Same idea. Total profit from marginal profit. So let's look at 27, then you can choose the next one. So we are given p prime of x, which is the marginal profit, 2x minus 150. A concert promoter sells X tickets and has a marginal profit function given by this. P prime is in dollars per ticket, of course, because it's a rate of change. It has to have two measurement units. Good. This means that the range of change of total profit with respect to the number of tickets sold, X is P prime. We know all that from previous chapters. Find the total profit from the sale of 75, from the sale of 75 through the 300. So they're giving us a range of number of tickets between 75 and 300. Okay, so first of all, we have to find P of X. And then we have to look at the interval 75 to 300. But first we have to find the profit function. Okay, so which function prime is 2x? 2x squared over 2 minus. Which function prime is 150? 150x. And plus a constant c. This is a family of function. All of them have the same derivative. And of course, I will simplify these two. Now, oops. Very good. Good, page 2. So now, because we're asked to find, Matthew has some issues with his computer. Okay, Matt, are you okay now? Is it your computer again?
Yeah, my computer glitched.
Okay, good. So what you missed was finding the antiderivative. So 2x squared over 2 prime is this function prime is this, and c prime is 0. That's all we did. So now, all we have to do is find P of 300 and subtract P of 75 in order to determine the profit from 75 to 300. And you know what I'm going to do? I'm going to put the function in and plug in these numbers. You can say, wait a minute, but what are you going to do with C? Well, C doesn't matter because I subtract. So I will have 300 squared minus 150 times 300 plus C minus 75 squared plus 150 times 75 minus C. And C with C will go away. Okay, I don't need to determine C in this situation. Good, so we are going to plug it in the graphing calculator. So in y equals, and some of your tests I still see that you plug in instead of putting everything in the graphing calculator. It's up to you. You're working much harder. Okay, and minus 150x. It's up to you. I don't recommend it. So we plug in 300, we plug in 75, and we subtract. So when I plug in 300, I got, let me double check that this is x squared. Yes, minus 150x, correct. Okay, so when we plugged in 300, we got 45,000, but then minus with minus in front, plus 5625. Okay. Very good. So what do we get? So we get 625 and 0 and 5. And that's it. Good. Moving on. Let's take a look. Maybe something else is... Any questions? I'm sorry, I forgot to ask. Any questions? Any questions? I will discuss this notation in a minute, but I'd like to work on another problem, and then we'll discuss this because it looks fantastic. It's not at all. You'll see in a minute. So total cost from marginal cost. Total cost from marginal cost. Okay, let's do 33, unless you want to choose something else. So we have C prime, which is the marginal cost, negative 0.04x plus 85. And, oh, actually, I wanted to look at the C prime of x, negative 2 over 25x plus 50. That looked, the function looked less, the first one looked less interesting. Find the total cost of producing the first 200 dresses. So we don't have to subtract anything like we did with 375 in this case. All we have to do is just determine the total cost for producing 200 units. Okay. First, we have to determine the most general antiderivative. So that will be C of x, negative 2 over 25 times x squared over 2, because x squared over 2 prime will be x, and plus 50x. Because we are looking at the first 200 units, it means that C is 0. Okay. So I'll simplify a little bit. So then C of x equals negative x squared over 25 plus 50x. All I have to do is find C of 200. And of course, again, you know what I'm going to do. I'm not going to calculate anything by hand. If I can quickly put it in the graphing calculator, plus 50x. And all I have to do is plug in 200. 8,400. And this is the cost. So the cost is in dollars. Okay. So, any questions? Any questions?